Hi, I'm Rich with Inside HPC. We're here at the 69th HPC User Forum in Tucson, Arizona, and I'm here with David McCallum. David, you gave a talk today about earthquake simulation and exascale computing. We're on the cusp of these machines becoming available in the next couple of years. What's got you excited in your field?
Well, I think it's me and as well as our entire team. And we have been thinking and dreaming about being able to simulate earthquake ground motions at frequencies that are relevant for structures for probably 2 decades now. We haven't been able to do that because the computational resources to do that have just not been there. We could get to maybe 1 or 2 hertz, which is ground motions that vibrate at 1 or 2 cycles per second. Yeah. Unfortunately, many of the engineering structures we're concerned about and care about vibrate at higher frequencies than that. They vibrate anywhere from 1 to maybe 8 hertz. Mm-hmm. And so there's been a real disconnect between the computations we had and the frequencies we could resolve versus what we want to resolve. So the promise of Exascale that really has us motivated is that for the first time, we hope to be able to simulate those motions at much higher frequencies and thereby have a full look at how those ground motions impact structures.
Sure. Because we can't, in real life, we can't shake a real building and see if it falls apart. We have to use simulation, right?
We can do component testing on shake tables, and there's mechanical shake tables at universities, but you can't put a full-blown building on a shake table and shake that and test it. So the only way you can really test that structure is to do it virtually on a computer. So computational mechanics, both in ground motion simulation and in building simulation, has become tremendously important in the last 30 or 40 years. And so in some sense, Exascale is allowing us to sort of close that loop and bring those simulations to full fruition, where we can simulate both the ground motions and the structural response to those ground motions.
Okay, well, David, what's the end game here? Are we going to be able to design buildings that'll withstand, even the big one, as they say?
I think there's a couple of things that are promising. Number one, the promise of Exascale is that we'll have a better understanding of earthquake ground motions, how those motions interact with the structure, and how the structure responds. And when you have more knowledge, you understand how to do a better design of those buildings and quantify the risk to those structures and have a much better understanding of the risk. So the answer is you can build a safer environment as your end game. That's ultimately what you want to do, and save lives and property.